rational function, which is y equals 3 over x minus 2, then I look at the denominator. The denominator is going to get me the vertical asymptote. So I say y minus 2 equals to 0. Split at the equal sign, adding 2 to both sides. X can never equal 2. Therefore, my vertical asymptote is x is equal to 2. My horizontal asymptote in this problem is y is equal to 0, which means it's also the y-axis. In the next problem, we will not have y equals 0 as our asymptote. First, we sketch our xy coordinate system, and we sketch our asymptotes. I have x equals 2, and the y, it's not the y-axis, it's the x-axis. That is also my asymptote. So what I have is a graph that looks like this. Sketching it, it is over here. Let's look at another example. Y equals 4 over x minus 7 plus 2. Notice this plus 2 over here. Different from the problem that we just did. This plus 2 is our horizontal asymptote. And remember, this right here is our vertical asymptote. X minus 7 is our restriction. So we add 7 to both sides, and x is equal to 7. So graphing this rational function, I would first start off with my axis, and then put my vertical as well as my horizontal intercept. My horizontal intercept is y equals 2. So on my y-axis, I find 2 and draw a dotted line. That represents my asymptote. My vertical asymptote is x is equal to 7. Once I have my asymptotes, I can sketch my rational function in the first part of the new restricted areas here. So this is now my first quadrant, which is here, and then my third quadrant, which is down here. And that would be a sketch of this rational function. Now sometimes I'm going to want you to get specific and not just kind of eyeball the sketch. So the next example that we're going to do, we're going to actually plug in ordered pairs so that we can get a slightly more accurate graph. So let's look at another example that has a vertical and a horizontal asymptote. Y equals 3 over x plus 2 plus 5. Hopefully by now you're getting the hang of finding the asymptotes. I look at the denominator of the fraction that involves the variable, remembering the restriction that the 0 can never be in the denominator of the fraction. So I start off by saying x plus 2 is equal to 0. And solving for x, I get that x can never equal a negative 2. That is my vertical asymptote. So on my x-axis, I find negative 2, and I draw a vertical line through it. The number that's sticking out here is my y, or my horizontal asymptote. It is y is equal to 5. It is the line y is equal to 5. So on my y-axis, I find 5 and draw a dotted line through it, representing the asymptotes. My graph will come close to, but never come in contact with, the asymptotes. Now, like I said, let's play around with some ordered pairs to see if we can't get a better accurate representation of what this graph is doing. So first we're going to let x equal 1. Because when x equals 1, I have 3 over 1 plus 2, which is then equal to 3 over 3, which is then equal to 1. And 1 plus 5 is 6. I then let x equal 2. If I have x equal 2, I have 3 over 2 plus 2, which is then 3 over 4, and 5 plus 3/4 is just 5 3/4. Let's look at what happens when I plug in a -3. If I plug in -3, I have 3 over -3 plus 2, which is then 3 over -1, which is -3, plus 5, which is 2. Looking at one more ordered pair point, -4. 3 over -4 plus 2 would be 3 over -2, which is then -1.5. -1.5 plus 5 is 3.5. Now let's graph this rational expression. 1, 6 means I go over to 1 and up 6. 2, 5 3/4. -3, 1, 2, 3, up 2. -4, up 3.5. So now that we have a couple of points, we can go ahead and sketch our rational function.